Today is Thursday, August 25th, 2022. It is also day 403 of data science. And today I'm on Khan Academy and I'm on this little practice session that they have, which is trying to find the area above or below a point, which is really good for practicing normal distribution and calculating the probability and whatnot. But today I'm actually focusing on the context of the problem and not actually trying to solve the problem itself. So the context actually is the following. So a set of magical wand prices are normally distributed with a mean of $50 and a standard deviation of $4. And then I'll just disregard the last sentence. So my goal today is to generate a random sample from the normal distribution or from a normal distribution with a mean of 50 and the standard deviation of 4. Because let's say the case scenario is I'm a teacher and I want to basically just teach this subject to my class. And to do that, I would want to have them start with the data and then have them figure it out themselves, like what's the mean and what's the standard deviation. And so I'll go ahead and start doing that. So the first thing that I would need is I would need to import NumPy as NP. And then I'll just write my values. So the values I'm going to get is basically just random numbers from a normal distribution with a mean of 50. So I'll go ahead and set those variables up here and a standard deviation of $4. So I abbreviate that as STD. Okay, so the values, I would do NP, and then I would use this function from NumPy, which is random and then dot normal. So I'm going to get a random sample from the normal distribution that has a mean of 50, a standard deviation of 4, and then the size is going to be how the format that you want your output to be. So real quick before I get to that, loc literally just means the mean. So you put the mean in here. You could have just done 50 and that would be the same thing, but I always like using variables. Scale is a standard deviation. I remember it by just knowing that S goes with S, so scale, standard deviation, and whatever's left is the mean. And then size is the last parameter that this function takes in, and size again is just how you want your output to be. So this right here outputs an array. So you can think of an array as a list, but really it's not. But it's just it's kind of like a list, but it's not. But either way, you could have an array with one column or two columns or three columns. So you can specify here the rows and columns that you want. So let's say I want 500 rows, so that would end up being 500 magical wand prices, and then just have that be in one column. If I were to run that and output that, I would get an array of 500 magical wand prices, and they would all be in one row. If I were to do 2, then I would see 2 rows of 500 magical wand prices. And so essentially what I'm doing is getting 2 samples, right? So this is 2 samples of magical wand prices, 2 sets of 500 samples. But I want just 500, and that's just going to give me one array, because if I do this, right, if I do one column, that's going to be a 2-dimensional array, and that's not going to really work with the pandas data frames. And I'll get to that in a few seconds, but for me, so I can convert this into a pandas data frame, I'm just going to leave it as 500, so it's a 1-dimensional array because that's what pandas takes. So talking about pandas is a data analytical library. So I'm going to import it as PD. And the reason I want this is because I want to make a data frame with these values so that I'm able to graph it and manipulate it and just analyze it, right? Because that's what pandas is for, analyzing and visualizing. Well, not visualizing. It has graphing functions, but I use Matplotlib for that and Seaborn. But the point is, pandas is to analyze data. So I want to have my data become a pandas series because that is what a column is called in a data frame. So first of all, let me create my data frame. I'll do pd dot data frame. So that's the function that you use to create a data frame. And then in order to figure this out, I would simply just do, well, actually, yeah. So I'll do pd dot data frame. And what you do is you take in a dictionary. And so the first part would be the name of your column. So this would be magical wand prices. And then the second part after the colon is the actual values that you want. So they usually are in brackets. So you could do 2, 3, 4. And if I were to run that data frame, that I would only get one column of magical wand prices and then 2, 3, 4. But I want these values to be in those rows, right? So in order to do that, I'm simply just going to write values and run that. And now I have the magical wand prices, and they're actually real magical wand prices that were sampled from the normal distribution, given that the mean was 50 and the standard deviation was 4. And so now I have that, which is pretty cool, and I have it all the way to essentially 500, but because Python starts with 0, it's going to end at 499, but it's technically 500 because 0 is still there, it counts. Anyway, so that's one thing. And then from there, I can use, let's say, Seaborn. So I can do import Seaborn as SNS. And then I can do sns.histplot to get a histogram of this data. And then I would just put in the df. And then write like the column that I want to plot, magical wand prices, run that, and hopefully it works. There we go. So essentially, if I was a teacher, I would just start with this data frame. I would be like, okay, here's the data frame. Now, please find the mean and please find the standard deviation. And then I would be like, okay, solve this problem. Like, what proportion of wand prices are lower than the price of a blackthorn wand? So actually, I might as well just do that, right? So let me do that. So this is the graph. So again, I'm pretending that this is what I started with. Like I never actually did this, blah, blah, blah. And I'm just going to start again. So let me do like a little break line over here. And then just let me screenshot, because this is what I always do. Let me screenshot the whole problem. And just copy that and then go back over here. And then text and paste that in there. Text, okay. So this is the problem. This is usually how I start like my other videos, but yeah. So I have the data now, so really what I'm going to do is just get this down over here, and this is my data. And from there, I don't really have to do like the math. Actually, I do have to do the math. So let's just pretend that I don't know what the mean is and I don't know what the standard deviation is. But I do want to know what proportion of wand prices are lower than the price of the blackthorn wand, which is 45.20. So from here, if I was a student, okay, I would be like, all right, so if I want to figure out the mean, then I'll just do df and then get the column of the column that I want to find the mean, and then just do mean, and then run that, and I get 49.90, which is literally 50, right? Rounded. It's 49.9, which is pretty close. So you can see that the sample data from the normal distribution is mostly accurate because it is 49.9, which is essentially 50, and that is the mean in the problem. And if I were to do df, let's say magical wand prices, and then get the standard deviation, which would be STD, run that, I would get 3.9, which again is essentially $4. And so that's how you can verify that your samples are essentially correct. And so as a student, okay, now I know that my mean is 49, blah, blah, blah. My standard deviation is 3.9, blah, blah, blah. And so I'll just set them as variables. And then the next part, which is kind of like even an extension of this, is figuring out the actual answer. So if I know that a blackthorn wand has a price of $45.20 and I'm trying to figure out what proportion of wand prices are lower than the price of the blackthorn wand, then what I would do is from scipy stats import norm, the norm function, because I need the norm function to actually work with the normal distribution. So from there, oops, I would just do norm.cdf, and then norm.cdf takes in, again, essentially the same three parameters. So it takes in the loc, which is the mean, it takes in the scale, which is the standard deviation, and then, well, the first thing would be actually the point that I want to figure out the area or the proportion below, and that would end up being x, I believe, and that's 45.20. And then if I run that, it's going to give me this. So just to kind of walk through this, so I'm going to use the normal distribution, and I'm doing the CDF, which is the cumulative density function. So I'm finding the cumulative density of this point. And so what that's doing is, if you take a look at the graph over here, let me actually copy copy image and go to my whiteboard over here to give you kind of a visual of what's going on right now. So I just open this up real quick and just paste that in there. All right, so what's going on right now, let me just lock it real quick. Okay, is 40, what was even the 42? Was it 42? It was 45.20. So the x, the point of interest is what I like to call it. The point of interest. Oops, my marker isn't working. Is 45.20. So what I'm looking for in my normal distribution is about here. And so what CDF does, it takes the cumulative density of all of the points before that point of interest, which is x. So it's basically taking all of this density and adding it up, and that is the value that I'm getting. And we got what, like 0.11, and that makes sense because 0.11 in comparison to all of this should be less than all of this, right? Because this to the right should be definitely way bigger. So that's what CDF does in Python. It calculates the density or the proportion or the area before or lower than a point. Yeah, so yeah, that's it. Let me go back now. So that's what CDF is doing. And so Khan Academy wants us to round to 4 decimal places. And so I'll just go and set this equal to an answer and then just round answer 4 decimal places. And then put that up here. Check. What do we do? Let me see. 45. Oh, because it has to actually be. What if I do mean equals 50? Standard deviation is equal to 4. And then put that in there. There we go. Okay, so just to keep in mind, I guess you have to actually use the exact values. But yeah, it still would be right with the mean and standard deviation that we have here. So now that I'm thinking about it, it's not going to give you exactly, maybe I should round, right? Maybe I should always round to, what do you call it, to the whole number. So I guess my big takeaway from this is that when I'm sampling, like let's say I have this Khan Academy problem and I'm a teacher and whatnot, and I want to kind of just create the data set, in order for your students to actually get the correct mean and standard deviation, like exactly right, just tell them to round up to the nearest whole number. And so I'll actually do that here. So I can just take the mean and set that equal to round mean to, what would be the first place or the 0th place? Let's see what that gives me. Whoops. What if I did 0? There we go. So 0th place, I guess. And then do the same thing for the standard deviation. And then I wouldn't actually have to do this. Let me delete that and then just do std, std. What did I just do? std, run that. 4, and then run that, and then I should get the same thing. Perfect, and then it would be right. So that's my takeaway. Always have your hypothetical students round to the nearest whole number so that it's actually exactly what they're looking for. All right, so that's that. We love learning. All right, and then I just wanted to kind of go over a few things. So right now, if I go back to the beginning, when I created my data frame, I gave it a size 500, but let's say I want, I don't know, maybe I want to compare different samples of a distribution. So what I'll do is, let me just copy this and start a new section down here. Paste that in there. All right, so, what was I gonna do? Oh yeah, I was going to do this again. So essentially, sometimes, we do want to plot a two-dimensional array with Python. And Python doesn't just do that with the format that we not with Python, with pandas. Pandas doesn't do that with the format that it is right now. So in order to plot a two-dimensional array, you might be asking, why would I do that? Because maybe I want to have like to compare multiple samples. Maybe I want to have like just multiple samples of magical wand prices in one big data frame, and then like plot the different distributions, which they should look the same, but plot the different distributions and compare them or whatnot. And so the way I would do that is I would just do, let's see, df. Well, first of all, let me get the values. So values would be equal to np.random.norm. Is it normal or norm? I literally forget. Normal. And then again, the same thing, like the loc would be 50. I'm just gonna do this for time purposes. Scale 4. And then the size, the only difference now is that I would want 500 and then I want 2. So basically what I'm doing is I'm getting 2 random samples of 500 magical wand prices. And if I run that again, whoops, okay, let me actually run it. There we go. So let me just go to the top. I don't know why it always takes me to the bottom. So now I have basically two columns of random just magical wand prices. And what I can do in pandas is I can plot these in pandas. So I can do df and I can do pd.dataframe. And instead of passing in a dictionary, what I would do is I would just pass in the values and then I would give the names to the columns here. So then I would do like sample 1 and then I would do sample 2. And so these are basically the indices for the columns in the, what do you call them, in the array? Yeah. And so here, like, this is amazing. So now I have like sample 1 and I have all of its like data, and then I have sample 2, and they're both coming from the same normal distribution with the mean of 50 and a standard deviation of 4, but they're random samples, which is like amazing. So this would be like sample magical wand prices, and it would be like sample 1 or something, or sample A. And so that's exactly what we're doing right now, and this would be like sample 2. And then in the previous thing, right, in the previous thing, it would have just been like a sample. I probably should have done like a sample of magical wand prices. And then, oh, well, that would like mess things up. But let me go back to the top. And then, where's the stuff? Okay, here, run that. And then it would work. So it'd be a sample of magical wand prices. It's not necessarily all of the magical wand prices, but it's a sample from the normal distribution given the mean and standard deviation. But I'm just going to leave it the way that it was. And then just go back down. So now this is like really, really cool. So yeah, so that's one thing. And then let's see what else. Okay, so now maybe I'll just show you like the purpose of maybe why I would want to do this. So I would probably want to plot the histograms for both of them and compare them. And so this kind of like involves Matplotlib too. So this is kind of like such a beautiful like lesson, because it's like it involves so many things, and it's just showing the usefulness of such libraries. So first of all, import matplotlib .pyplot splt, and I already have Seaborn imported, so that's fine. So basically what I want to do is just plot two graphs in like a figure, which you can think of as like a canvas when you're painting, and whatever you paint would be like your graphs. So the figure is a canvas, and whatever you paint would be your graph. So if you have one figure, you have one canvas, and if you have two graphs, then you have like two things that you painted on your canvas. Same thing. So in order to create the actual figure, I would do plt.subplots, and then I would just do fig size, which is just a parameter, and that's just in parentheses, just like 10 or just 5, and it's just like width and height. So like 10 width, height 5. And then I would just rearrange that however I want. And so it gives me a canvas, it gives me a figure, right? With those sizes, the width and height, so 720, 360, same thing. And I could specify the number of rows and the number of columns that I want. I believe, hold on. Is it n rows? Yes. Number of rows. So I want one row, and then the number of columns that I want is 2, because I want 2 columns, right? 2 graphs, right? So then that would end up looking something like this. So now I have 2 columns and 1 row, right? So I have 1 row, 2 columns, and 1 row. Okay. And now if you notice, this returns obviously the figure, and it also returns the the figure itself and then the axes. And so super cool thing about this is that I could actually in the way to access these is by setting them equal to variables. And so because it returns it this way, I can just do fig and then comma axes and set that equal, and then now I can access the figure of that is returned by this function. But here's the problem. If I run this, I noticed though, well, actually you won't notice until you actually start doing the work. But because there are two columns, meaning there's two graphs, I would actually have to do comma and then do AX2. This is the same thing as doing graph one. You can name this anything, like graph two, if that's like more intuitive. I'll leave it like that. But yeah, so it's like graph one, graph two, and if I run that though, it's gonna give me an error because when I have multiple things, I have to put them in parentheses, and each parenthesis represents a row. So now everything is good. And if I were to have another row, then I would actually have to do comma and then do like graph three, graph four, whatever, because each parenthesis has to represent a row. So anytime you see like parentheses and like items and variables in a parentheses, in this case, it means that they're all in the same row. So that's that. So now I can access both graph one and graph two and the figure, which is pretty amazing. Now, what do I want to put in this? Well, I want to plot the histograms of these two little data frames, or not data frames, series. So I could do that by doing same thing, sns.histplot, and then just taking df and then sample, I believe it's sample one. What was it? Sample one. Let me just copy and paste it. Paste that in there, and then run that. What is it now? Sample one magical dot prices. Is that what it says? Sample one magical one prices. Okay, just run it again because sometimes if you run something before, things get messed up. Go scroll down. Okay, there we go. It works. Probably because I ran like a data frame again from the early ones. All right, so this is the histogram for the sample one, magical one prices. Okay, and now I'm going to do the histogram for the second one. And so I'm just going to do new code. I'll literally just copy this one and paste it, and then I'll just do sample two because I know that it's the same thing, run that, and then it should give me the histogram for sample two. And they should fairly look the same. Like notice that the 50 is in the middle, and that makes sense because the average is 50, right? The mean is 50, and they have a standard deviation of 4. So each of the data points, each of the magical wand prices deviate for what is it, $4 from the average. So that's that. And then this is taking long. Did I spell it wrong? Hello? Did this thing just disconnect? Okay then. Well, this thing is frozen, so let me just take a second and wait. All right, so now I finally have my graph here. So I have both graphs. Again, they don't look exactly the same because again, they are samples from the normal distribution of like just 500 data points, or 500 magical wand prices, but they are like overall the same because again, the mean is 50. It's at the center as it should be. It's normally distributed and fairly symmetrical, right? That's what a normal distribution is. Okay, and then let's say, again, I want to plot these inside these figures. So the way that I'll do this is I'll just bring this block down over here, and Seaborn has this attribute called AX, and I can set that equal to the graph that I want. So for example, if I want this to be graph one, if I want this to be at the first little box here, then I would just set it equal to graph one. Why? Because graph one is literally graph one. So actually, maybe I should have left it at the top. But now I can do graph two here and then just run this, and when I run this at the top, those plots, okay, let's put that down there. Interesting. All right, so I was questioning why this wasn't working. So, I think I just forgot, where is it? This. Parentheses in here. Let me run that, and then do this, and then do that, and then do this. Let me go put this all the way to the top then, run that, then this and that. I wonder why it's not working. Okay, give me 1 second to try to figure this out. So AX, graph 1, and then graph 2, and then I have parentheses here, and it has n rows 1, n columns 2. Let me put that at the beginning. And then comma here. I wonder. You know what it might be? It might be the fact that it's not in the same line of code because it's kind of making it awkward to run. So instead of doing that, let me just put this at the top here and then put this one down here. Whoops, did I just... Okay, that's great. What did I just do? Oh my god, I just deleted... Where did my stuff go? Alright, this I don't want. I'll have to rewrite this one. Just paste that in there, sample 2, and try to see, change this to sample 2 also, run that. There we go. Okay. So yeah, that was a different thing I did. So essentially, apparently another takeaway from this is that I have to have this all in the same line of code. Because as I was like running it, I didn't know in which order to run it, which kind of made me think, is something gonna go wrong? Because yeah, like it doesn't make sense. Like, do you run the graphs first, or do you graph, or you do this first? Because but then if I do this first, then how would this know? Blah blah blah. You know, it just doesn't make sense. So have it all in the same line of code, and Python figures it out. So, okay, so essentially just to kind of summarize, I use matplotlib, that's how you actually get the figure itself, and then Seaborn you can use to actually graph the histograms. If you want to use matplotlib, then I believe that you would have to do AX, like you would just have to do like graph1 dot plot and just think of it instead of matplotlib.plot, just do graph1.plot and then put in whatever. I don't know if there's, I barely, let me search up if there's a matplotlib histogram. Is it just hist? Let's do graph1 dot hist and see if that works. If I do df, because I barely use matplotlib for actual graphing, I just use Seaborn. Oh yeah, it works. All right, so yeah, that's how you would do it in matplotlib. You would just instead take the graph itself and then do dot hist because again, it's an actual matplotlib object. So you could just do that. But if you're graphing from like another library, for example, Seaborn has its attribute AX, which is useful because you could just paste that whatever your graph is called. AX is just another way of just saying your graph, like your whatever your graph is, that's what you put in here. Like you're just assigning it to graph 1. You're assigning this histogram to graph 1. But this is how you would do it in Matplotlib if you want to do like a histogram in Matplotlib. You can clearly see the difference between Matplotlib and Seaborn. But yeah, I don't do Matplotlib, so we stick with Seaborn. Yeah, so that's what it is. And let me just make the sizing a bit better. So maybe like 12 for the width. Have that something like that. And then to make it pretty or prettify it, I don't even know. I could also add, let's see, like titles. So the way I would do this is I would just do graph1 dot set title. So instead of like just using title like you would in matplotlib, you would do set title. And then I would just literally copy and paste this. And then run that, and I should see it in graph 1 over here. Beautiful. And then I would just do the same thing for graph 2. Just change that to graph2 dot set title. Run that, and I'm setting the title for graph 2, although it's supposed to say sample 2, not 1 or 3. All right, that's beautiful. And I would just also change the X labels, so I could do like, let me just kind of separate these. I'll just move this one down here for like graph 2. Let me make it organized. And then graph 1. I could do graph 1 dot set X label, because that's the X-axis label, and just set that to magical wand prices. Same thing for this one. Run that. And now I have magical wand prices, magical wand prices. Beautiful. And then the count. I could also change, let's see, graph1 dot set y label and change that to density or to the proportion. It could be anything. Well, not anything, but obviously in accordance to the problem, run that, and now I'll also change the y label. If I want to change the background color, I could also do that. Let me just get an actual nice color. Let me do palette generator. I already used purple once. Let's do blue. Actually, no, I love purple. I mean, even though my favorite color is blue. Okay, so to change the actual background of the figure, you would just do fig, well, which we haven't actually done, actually. We haven't even touched the figure. We could do fig dot, set, is it set face color? Yes, face color. And then just, I believe I could just paste that color in there. I'd have to do hashtag, run that, see if that works. Beautiful. So now I have like the background color. I set the face color of the figure. So that's one thing. I could also set the face color of the, what do you call it, of the graphs themselves. I'm not sure if it's supposed to be face color. Could it be the same thing? Let's try that. Yeah, beautiful. So that works also. I could do the same thing for this one. So let me do that here. Just run that there. Oops, I just forgot to change it to graph 2. Run that. All right, and then if I want to change the bar colors, that's actually something that you would do in Seaborn. So I believe in that case, I don't know if it's just colors, and I could do hashtag FFF, which is white. And I don't know if I have to do color or colors. So we'll see if it gives us an error or not. All right, so maybe it's color. Or is it palette? Sometimes it's palette. Oh, there we go. So that works also. Um, yeah, I probably could do like a darker shade of that. So let's do like maybe this color so it stands out more. I feel like that would stand out more than white. Beautiful. So yeah, so this works. So that's how you make it pretty. And yeah, that's kind of like a use case of maybe if you want to just like sample random samples, sample random samples, like retrieve random samples from a normal distribution. And if you want to have them in the same data frame, it's a good way to graph them because you could just, just target the data frame, right? So data frame and then the name of the column that you want to have the histogram for, and boom, just have it there. It's pretty cool. That's another use case. And then another thing that I wanted to mention, sometimes, let me just go all the way up. Sometimes, like me personally, I started off with doing like comma one and then trying to pass that in. And it is, well, let me rephrase. I tried doing this and trying to pass that in as a pandas data frame with the way that I did it, just like the normal way with, this way. And it wouldn't work, but I figured out a way to do it. I would first have to convert it to a list, which I did a video on this literally like 2 days ago or yesterday, I don't even remember. Convert it to a list, and then I would actually have to get rid of the brackets, which is really funny because if I just knew that it was like an array and that pandas doesn't take two-dimensional and only takes one-dimensional, I would have realized that, hey, maybe I just have to, just turn it into a one-dimensional array, which is just by not having this one here. So that would have just saved me a lot of trouble, which, I figured out today. And then what else did I want to mention? Let's see. I could also I would have thought of converting it to a pandas series, but it's the same thing. I would actually have to change to not have this here. But yeah, there's different ways to figure this out. But yeah, I think that's enough for today. I really incorporated a lot here. Um, yeah, so I'm gonna go now and bye.